Why would 10-1A be the hardest one to get into? So many people are trying.
That's what I think is the hardest one.
Because you have a lot of engineering, all of the community, all the bio's really hard there too.
All the nursing and stuff.
Yeah.
There's 1A though, I don't think nurses.
It's all between that.
You guys, technically speaking, I don't know how to answer your question. I don't know if you need to know anything. I mean, I'm going to ask you a question like, if I do ask such a question, it's going to be, create that differential equation. This is an application. I don't care if you guys remember this equation. I will give it to you if you need to use it. Now, I guess I can ask some simple questions like, can you identify your transient and steady state solutions? Would you be able to do that? Brad?
Can you show us?
Yes, I can.
All right.
Because I think if you solve the DE, oh, you guys didn't bring pens, darn it.
And so then we just derive the DE. That's what you want us to know how
Yes,
to
and
derive
if
it.
you came up with a
Okay.
solution like this, I think when you take a peek at this portion of your solution, and this portion of the solution, I think they're dramatically different. Because I think as t increased that bound, what's going on with the second portion of my solution is, well, something pretty darn standard going on. Is a sinusoidal wave. Could you give me an amplitude? I asked you, could you give me an amplitude? You should sit.
Isn't it like both coefficients squared added to each other, the square root of that?
So in other words,
Okay.
As a magnitude?
yeah, in other
Four,
words,
square root, the dot root 29.
So you just take,
square root of 29
yeah,
over that.
take the
Mark is
magnitude.
what you're saying. It's square root of 29.
Okay.
Oh.
I see.
Yes, Michael.
It's math 32.
Like, I don't think it was the same, like, regular, is it like the regular magnitude where it's like you're taking 5 times root 2 divided by the sum?
So just the same thing we do in math 32, right? Where you're finding the magnitude.
Hold that thought. If you don't see it, Michael, I'll talk about it in a second. First things first. I do think I can subclassify this portion of my solution as my steady state solution because it's sinusoidal, it's doing what it's doing repeatedly, it's not changing. I think I might refer to the first portion of my, I'm just talking too fast again, I'm sorry. I think I can refer to the first portion of my solution, my transient solution, because notice with that exponential factor, as t increases that bound, that's forcing the amplitude to go down to 0. That's why I refer to it as my transient solution. Are you there? Do you guys think you can tell me the amplitude of the sinusoidal wave? It's just 3. You see a cosine function? Look at the constant on the front. A sinusoidal wave with amplitude 3. If, however, I gave you an equation like this, I think here you should be able to tell me what its amplitude is. Because, well, I should slow down, shouldn't I? Maybe you guys don't look at this and you can see a sinusoidal wave. But I confess, if I rewrite the right-hand side as an a over the square root of a squared plus b squared times the cosine of t plus b over the square root of a squared plus b squared times the sine of t, I mean, they're basically the same, aren't they? Why am I using this? Do I get to sit again? They're basically the same, aren't they?
No.
No, I made a huge mistake. I don't think they're the same at all. I divided out.
You have
by
to
the garbage.
compensate by multiplying by
Yeah,
the square
yeah, I
root
really
of
messed
garbage.
up. I better
Yeah.
put it in. Now, I confess, I think it's a good game to play because technically speaking, when I just take a peek at a divided by the square root of the sum, I just instinctively think of a right triangle. Like here are two sides A and B. Here's the length of the hypotenuse. And why don't you guys give this angle A and call it a phi? I think relative to the triangle, when you look at that first fraction inside my set of parentheses, I think that first fraction could be interpreted, if you so choose, could be interpreted as a cosine of phi. It's being multiplied by the cosine of t. Plus my, oh, look at that fraction. That could be interpreted as sine of phi times the sine of t. It's just that now if I dive in and use my subtraction angle identity for my cosine function, oh, check this out. This really does look like a sinusoidal wave. I was too simplistic with my t, call it omega t, in order to change that to an omega t. I know I made a mistake with the direction. It should be reversed, but the cosine function is even, so who cares? That's why I maintain you guys should know that the amplitude is this way. Nothing ground shouting, just a tap of the truth. If you take a peek at what the author has done, he's done some funky stuff in this section. Like, for example, told you guys I need to change it around a little bit so I can copy it over. Take a peek at this particular solution here. Notice that you can think of this as basically the result of solving one of these equations. It's just that if your wave does look like this, there certainly is an amplitude that's max value. And he said, oh, use this funky little formula right up here. But that came from him rewriting his amplitude in this fashion as a function of omega, and he merely applied his math 30 skills, not that he showed it, and differentiated them. So I did not discuss it in some class. I just thought, you take a peek at it. If you want to come up with a quick way of coming up with maximum amplitude, you can use that formula. I certainly don't care.
Would you ask us anything like that?
No, I'd ask you to solve the DE.
You just asked us to solve the DE? Okay.
So I think you're looking into it too deeply in terms of what I expect of you.
Yeah, because I
Not
just,
that I expect less, I just don't want to go off into all this
I
other
just-
peripheral business.
yeah, I was just kind of looking at all of these formulas and just wondering, like, am I supposed to be able to drive each and every one of these, or
If you moved to class,
if so-
remember how much time I spent on this?
like 30 seconds?
Yeah, I spent
Yeah.
very little time. I made draw some pretty pictures and told you about Kirchhoff's law, where the voltage applied is going to be equal to the sum of the voltage drops on these individual components, the resistors, the capacitor, the
Oh,
inductor.
and you didn't do it right either.
Why not?
Because you got a 1 over RC times Q
Did I really?
instead of 1 over LC. Yeah, that's something I was noticing.
Ooh, I'll have to look at that.
Yeah,
And when I come to class and write this out of thin air,
yeah.
I never remember it.
Okay.
I don't commit it to memory. I just solve it out of thin air. What's natural.
Could you quickly derive it? with
I
us?
can, but I don't want to hold everything off too much on today, so maybe if
Okay.
I have time at the end.
Okay,
But you asked me what I expect.
Okay.
I just maintain if I give you this equation with these coefficients, I just want you to be able to plug things in.
all right.
But can you appreciate why I went through this material so fast in class? Maybe I took my time drawing pretty pictures, but in terms of solving DEs, it's just a matter of plugging things in, and now we're using the standard techniques we've had up to this point. I take that back. At this point, the only technique that we had was the method about determining coefficients. So I guess it was limited in that sense.
Okay.
Now, the author, he's writing a book. He doesn't want to do what I do, say it really fast, say, oh, it's just an example of doing what we've been doing all along. That's why he put in all the other peripherals, because he wanted to make it more interesting.
Okay.
That's just my opinion.
Did you ever figure out the problem we were working on Saturday?
No,
Do you want to ask that?
I forgot which one it is.
It was number 9, and the, which chapter was it? Was it 6.4? Yeah. 6.4, number 9. Because I couldn't really see what you were doing wrong. I didn't work on that one over the weekend. But probably should have. Yeah, I put a little arrow to it.
Yeah, I kept doing it over and over and I couldn't.
You were getting the ifs in the back.
Yeah.
Oh, shoot, I need to backtrack. The quiz I just handed back.
Yes?
So we got an exam in a couple days. Do you think we could do something different about that quiz? Can you just treat that as just a study question? So if you didn't do well with it, just go back, now it's back in your hand, and go back in there and solve that DE, and make sure you're getting what you should be getting. Have somebody else check it for you too.
Does that mean it's going to show up on the exam?
No, I'm just saying, I don't want to take much time in class before the exam, so I want you to treat that as a study guide, not a guide, a study example.
Okay.
So start from scratch and get some practice with your integration techniques. I wanted you to be able to integrate things like that.
Is there going to be a second test on the,
I don't know, is there one on there?
No, that's
There
something
isn't.
I was looking for that. There also was no take-home quizzes last weekend.
You guys, I after we met Saturday, I ended up
Okay.
helping so many people at home in math
Okay.
coming over. I just lost my fuel,
Okay.
and I apologize for that. Now that we got the exam coming, I thought of posting one today. It's just we got the exam, so it would be logical.
Okay.
Can you guys just remind me on Thursday? I'll post one right there in class. See, I went for the weekend.
So just study this for Cauchy problems?
Yeah,
Alright.
that was a good question.
Cool.
Calculus.
The Cauchy-Bueller.
I'm too tired to fight today. So you're saying number 9 didn't count?
On 6-4, yeah.
Yeah, it was. This is absolutely a
If you don't
Cauchy
wanna
problem.
do it
Oh,
now,
wait, no.
talk about it after class.
Because he meant to write a Cauchy problem, but instead he wrote a variation of
Right, I'm
parameters
waking
problem.
up.
Huh?
I'm waking up.
Okay.
I really am just too tired. I can't do it in my head. What about the homogeneous case? Oh, yeah, you can't read that. So is that going to be a negative b plus or minus square root of b squared minus 4ac, number 9, so minus 40, all over 2a. So that gives us 1 plus or minus, is that a 3, 9?
Yeah.
Now, I just want to look at my forcing function. Ooh, I see. So I think our complementary solution is going to look like this. That could be e to the x times c1 cosine of 3x plus c2 sine 3x.
Wait, aren't you looking at A and B terms here?
Not yet.
Not yet, not in this one?
Oh, Brad, I was just talking about complementary
Okay,
solution.
yeah, I see.
Now, you guys, whoever asked me this question, did you solve this using complex value solution technique or not?
Well, yeah, it's supposed to be a
Yes.
complex value
Yeah.
trial solution.
I did. And
Oh.
Sorry, I did not read the
But they
instructions.
don't even want the complementary solution, do they?
They don't want the complementary solution.
Yeah.
Oh, sorry, can I cross
You
this
just
out?
want to find the particular solution.
Yeah.
Oh, sorry, can I cross? I can't cross this out. This is
No.
important. It doesn't matter if they only want the particular solution. I have to generate the complementary solution to see if I have duplicity,
Right.
Okay.
and I do. So I think when it comes to my trial particular solution, my y sub p, I think it should look like this. Oh, sorry, I'm too slow. Is that going to be an x e to the x a cosine? Oh, I made a mistake. Sorry, I meant ax e to the x cosine 3x plus bx e to the x sine 3x. No one? What'd you say no?
Because the original doesn't.
Doesn't want.
You have to expand the original right side into the Euler formula, right?
Are you saying I've done something wrong? Mathematically. Remember, we have an exam today? I think what I did is fine, I'm just not following instructions. The author twisted my arm and using the complex value solution technique. Do you think I really should?
Why not?
Well, okay, but what if this were an exam question, and I didn't tell you what way to solve the DE? You think it'd be in your best interest to use a complex value solution technique?
You could just do variation of
Yeah,
parameters, right?
I think by far, you guys, look how miserable my life is. To pick this trial particular solution up off the board, and I've not made a mistake, and slap back in the DE, I've got to differentiate twice, and check out how each and every one of these terms requires a product rule twice. And so I just think it's so much work. That's why, without the instructions, I would have crossed this out and said, let's indeed give it a shot by allowing z sub p to be, sorry, I'm going so slow now. Is that an ax e to the 1 plus 3? I times x. Now I gotta confess, differentiating, I still gotta use a product rule. But at least it's a heck of a lot less work. Do you see my point? So whoever asked, is this what you have for your trial particular solution?
I think so,
Oh, it
yeah.
is. It's still going down.
Yeah, I had a hard time seeing what went wrong.
Yeah.
So on the exam, for stuff like this, are you going to ask us to solve it using complex trial or variation of parameters or anything
You know,
like
you
that, or
guys,
are you
when I
just going to put
posted
it on
an
there?
exam, I have no idea what it's going to say. I just know in the past, sometimes I said yes, sometimes I didn't.
Okay.
Did I lose something?
Instead of 8 to the 1 plus 3x, it should be
Oh, yes. And I can't simplify further. to differentiate a second time, do I need the second derivative?
Yeah.
Yes, it's second order VE. Does that give me a times -2 plus 6i?
Is that -2 or -8?
Yeah, right here.
Yeah. 1 plus 6i plus 9i squared.
Wow, you're right, I considered it out of 3i squared. Didn't I make that mistake twice though? So it should just be a -8 as well. Thank you. And in picking all this up off the inkboard, slapping it into the original VE, let's see, does that give my second derivative? Minus twice my first derivative. And then finally, plus 10 times the original, being equal to whatever the forcing function is on the right-hand side. But you guys, I'm cheating. I'm just dropping the e to the x times the cosine of 3x.
One quick question about
Sure.
the second derivative.
Yes. So right here,
Second derivative.
excuse me, here.
Is there also a term, did you differentiate the AE of the 1 plus 3ix as well? That's added in the first one.
I did, but I think I multiplied instead of adding. You can actually get a 2 plus 6i. Is that matching up with what you have so far? Or can you tell?
For the second derivative, I got something different.
What'd you get?
I got that first term. For the second term, I got -8 plus 6i times AE to the 1 plus 3ix.
Yikes. Well, see, when I differentiated the first term, I have to use a product rule.
Yeah.
And I differentiated the second first. That's where I got this.
Right.
Plus this whole thing where I've differentiated the first, which is just a times 1 plus 3i.
Right.
So I really should have had a plus a times 1 plus 3i times e to the stuff.
Yeah, that's, I have that there too.
It's just that when I add to this derivative the second term, that would just give me another one.
That's where you get the 2 plus 6i.
Did you see it?
Yep.
And so now it sounds like we differentiate, we differ
Yeah.
in our answers. Okay. Maybe that's where it
That's
is.
probably what it is.
Well, you saw me make 2 mistakes already, so it's easy to do. So you guys, this takes care of things. Let's you and I come back to this.
We get to fun stuff.
I want to talk about what it means to solve. The VDE, x bar prime being equal to ax bar, where a is equal to this 2 by 2. So you guys can just humor me. I'm just going to make an example up out of thin air. Use the example to talk about what's going to happen if I happen to have a VDE in which the matrix A is defective. If it is, for example, here are my examples. Where A is equal to, for example, 3, 2, -2, -1. Well, I think the first thing I've got to do is come in and find the eigenvalues. And in finding the eigenvalues, guys, let's see how proficient you and I are. Because we had a lot of practice. I think the eigenvalues are generated by looking at, is that going to be a lambda minus 3 times lambda plus 1? Is that plus a 4 being set equal to 0? Or shall I say, does that give me a lambda squared? Is that a minus 2 lambda plus 1?
Lambda equals 1 with a multiplicity of 2.
True, lambda is equal to 1 with a multiplicity of 2. So if I now try to come in and find the corresponding eigenvectors,
Would lambda be -1?
would it?
Yeah.
No, it'd be 1.
You guys just tell me if I'm making an arithmetic blunder.
No, you're right.
Now to find the corresponding eigenvectors, well, subtracting 1 off the main diagonal, whoops, I mean up here. Wouldn't that give me a 2, 2, negative 2, negative 2, augmented with zeros? Which reduces immediately down to this. Well, again, you guys, tell me if I'm walking too fast.
And so then you get a
So a single corresponding eigenvector, V bar, I'm not going to use subscripts, I've only got one
1 and
eigenvector.
negative 1.
You said 1, negative 1, I believe. Now, why won't that middle bar get cleared? So everybody, I think this is a clear example of a matrix that's defective. Because I've got a 2 by 2 matrix, if it were non-defective, I'd have 2 distinct eigenvalues. Excuse me, I misspoke. I'd have 2 distinct eigenvectors. So, given that it's defective, here's my approach. I will now find one solution to the VDE. In other words, no longer concentrated just eigenvalues and eigenvectors. And I think one solution is going to be this. x1 bar of t is going to be nothing more than that eigenvector v bar times e to the lambda t, which in this particular case means x1 bar of t is equal to 1 times e to the, I don't remember. Oh, it's clean. Nice clean t.
Yep.
Now, if you guys don't mind, I'm going to deviate from the text a little bit. He starts talking about my solution technique to a VDE in which I've got a defective matrix, and then says, we can simplify this. I don't think his technique simplified at all, personally. But if you like it, stick with it. I'm really lazy. I don't remember anything. So my technique is the following. Since I don't have a second solution, very similar to how you and I removed duplicity when it came to solving just higher order DEs, not VDEs. I'm going to allow my x cubed RT to be equal to, I don't know, some vector, I'll call it v sub naught bar, plus t times b1 bar, times my e to the lambda t, and lambda is equal to 1. If I merely allow my second solution to look like this, then I think it's my responsibility to find the vectors v sub naught bar and v sub 1 bar. By the way, I'm not making any mistakes. Those are bars. These aren't components of vectors. These are vectors themselves. Brad.
The book would label that one v sub naught.
Yeah, I know. I just didn't care because I've only got one vector.
Okay.
I tend to be a little more careful with vectors if I already had more than one with a bunch of eigenvalues.
Okay.
And besides, they're just subscripts, so who cares what you call them? I also maintain that substituting this in the original VDE, something really nice happens. When I pick this up off the ink board, I guess on the left-hand side I've got to differentiate. And to differentiate, well, I'll be careful now. I think I've got the first times the second. By the way, I'm losing track of what I'm doing. Am I differentiating with respect to V naught or V1 bars? Neither. I'm differentiating with respect to the independent variable t. So here's the first, which is a function of t, times the derivative of the second, which is e to lambda t times lambda. I just got lucky in this example. Plus the second times the derivative of the first. And this should be equal to my a times x bar. Well, that would just be a times this x bar. Now, in equating, constant terms and coefficients of t. Well, you guys notice how I think have things combined very easily in terms of coefficients of t and constant terms. So I got an idea. Let me remove parentheses here and here, and let me re-colocate all the terms not involving t. I think on the left-hand side of the equal sign, that would tell me this, that v sub naught times e to the t plus v1 bar times e to the t, and then collecting all my terms involving the variable t, would that give me a t times v1 bar times my e to the t? Now on the right-hand side of the equal sign, I'll list my constant term first. That would be a v naught times e to the t. Plus my t term second, but that would be an at, is that v1 bar, e to the t? So when it comes to my coefficients of t on each side of the equal sign, check out. I think the coefficient of t on the left-hand side is nothing more than v1 bar times e to the t. And I think the coefficient of t on the right-hand side of the equal sign is just simply going to be an a times v1 bar e to the t. Oh shoot, I'm wasting ink, you guys. I got the e to the t in there. Can I rewrite that? I think what that means is v1 bar is equal to a v1 bar. By the way, what's the coefficient of v1 bar on the left-hand side? 1, which happens to be my eigenvalue, which necessarily means that a is going to be, or excuse me, v1 bar is going to be the corresponding eigenvector, or a corresponding eigenvector, with respect to the matrix A, when the eigenvalue is 1. Do we have any such eigenvectors? Yeah, it's listed on the board over there. I'll steal it. It's just 1, negative 1. So we will choose v1 bar, whoops, I'll write it so you can read it, to be nothing more than 1 comma negative 1. Remember, you guys, I'm proclaiming my second solution looks like this. I got to find v sub naught bar and v sub 1 bar. It just doesn't have the job. Now to find v sub naught bar, notice when I equate coefficients, or excuse me, equate constant terms. On the left-hand side, I'm left with this. v naught plus v1 all times e to the t is equal to a v naught e to the t. Simplify this. Doesn't that imply this? Yes. Bradley?
I was just gonna point this out because it is a little confusing.
Ooh.
The book labels your V naught up there as V1 and your V1 is V naught.
And I don't care
I don't really think it
whatsoever.
makes a difference,
No,
but
it
it
makes no
just
difference
looks a
at all.
little weird
When I write on the board, I never pay
Yeah.
attention. I don't care what you call them. Call them V bars and U bars if you really want to.
Okay.
It's completely irrelevant. Well, I think it is relevant once you label them
Yeah.
to keep things straight, only because I'm going to come back.
Yeah.
But jeepers, what you call them initially, I don't care.
Okay.
What happened to the t when you were looking at coefficients?
You know, if I'm just simply equating coefficients of t on both sides, I think all I really have to do is this. Here's a coefficient of t on the left-hand side of the equal sign. Here's a coefficient t on the right. I'll just equate those coefficients. Yeah, I could have put it in. Oh, by the way, I just slipped up, you guys. I really did. Sorry. Well, I didn't make a mistake, but technically speaking, lambda's specifically just 1, isn't it?
Mhm.
Oh, but shoot, look what this does. This creates for me a nifty little augmented matrix. And so I maintain you guys, I think I just made a more serious mistake. I really did. Sorry. If I sail this thing to the right-hand side, doesn't that really tell me this? That my A minus lambda times I times my V naught bar is equal to my V1 bar. I'm looking at what I have writing on the board. It doesn't make any sense to me. I did my arithmetic correctly. Now, if I were to set up an augmented matrix, taking my matrix A and subtracting 1 off its main diagonal, you guys, it's way too far away. I took off my glasses. Somebody give me that matrix A in the original VBE and subtract 1 off its main diagonal. 2. Oh, but I'll be augmenting it with V1 bar, which I just found to be this. Now, if I were to reduce this, wouldn't it look like this? You guys just lost track of what I'm doing. When I set up this augmented matrix, what am I looking for? What am I solving for? Give me some symbols. V sub naught bar. And you guys, let me just label things clearly. Where V sub naught bar has component sum, how about V1 and V2 as numbers? Doesn't the very first row really tell me that V1 plus V2 is equal to 1/2? Now, you guys, can I find combination of values for V1 and V2 that can be anything in normal, please? Anything? Except for one. Yeah, maybe along the way, if 0 satisfies this equation for V1 and V2, you should reject that because you don't want a 0 vector. Because the eigenvectors are not going to be 0 vectors. But I gotta confess, if I allow V2 to be equal to V2, excuse me, to be equal to 0, then V1's not equal to 0, is it? So it's perfectly legal. You can allow V1 or V2 to be anything you normal, please, and satisfy this relationship as long as you don't generate the 0 vector. By the way, this is what makes my life really fun grading, because I don't choose different values. And you know what I think I just did? I'm running out of room, but I think I have just found the components of the vector I'm stalling because I don't remember. Of V naught bar. And so on the sidebar board, you guys, since I'm running out of room, I think I have now just found V sub naught bar to be equal to nothing more than, is it 1/2 comma 0?
Yeah.
Which means x2 bar v is going to be nothing more than, if you look in the middle import, is that a V naught bar plus t V1 bar times e to the t? Or in this particular case, I think that gives me this 1/2 0 plus t times my V1 bar. Was that 1 negative 1? Times e to the t. Or shall I say, this is a single vector that's 1/2 plus t comma negative t times e to the t.
So can you quickly?
Well, that's not the final answer for the solution to the
Oh wait, no, I see what you
But it is
did.
my final answer for x2 bar t.
Never mind.
Michael?
So for the last step, would you, I guess, combine your x1 and x2 and add a c, a constant in front of those?
Very nice. So I think in the end, what I'm really going to get is the solutions involving c1 times c2 times the x1 and x2. I think in the end, here's what my final solution is going to look like. So all solutions x bar t are going to be a linear combination of my first one, x1 bar t, with the second one, x sub 2 bar t. Now I think in this particular example, that means the following. I don't know what it means. x1 bar t is what, negative? Plus c2 times x2 bar t, which I found to be 1/2 plus t, negative t. You guys, did I miss anything? Yeah, I think I missed a very important factor. It's just isn't common with all the terms, so you might have just pull it out. So we have just solved a VBE where the matrix A happened to be defective. Why won't you turn off?
I'm just kind of wondering why you have a V2 value there.
Brad, I only put this in the board for this reason. I was worried that we'd all lose track of what the heck I'm solving for. Because I think when I solve, or reduce, I should say, an augmented matrix,
Yeah.
it's solving a system of equations.
Okay.
In terms of x's, y's, z's, what are they really representing? Well, I think these are coefficients of the components of my
Oh,
vector
okay,
d
okay,
sub
okay,
dot
okay, I
bar.
see,
I just
I
made
see.
these letters up out of thin air again.
And so you just let V2 equals 0 because.
Well, yeah, you check this out.
goes
I
to-
just need an eigenvector.
Okay.
And I think this relationship right here,
So you're just looking for something that satisfies that.
is true, but I take this back. I said eigenvector. I'm looking for a vector that satisfies this condition, just one of them.
Yes, yeah.
And I just grab one to make my life easy, allow V2 to be 0, or V1 to be 0, or maybe there's another number you find more convenient.
Okay. And so really the only difference from the way that you're doing it and the way the book does it is the book will take that term to the multiplicity.
Yes,
Whereas
I agree.
you just put it into a matrix.
I
Okay.
agree. He's still solving systems. You guys, I want to at least do this with a 3x3 matrix. So, 3x3 matrix. Let's solve this VDE. Where A is equal to... You guys, I really don't know how it's going to work out. I just know the other week I made up some examples. How about A is 1, 2, 0, 2, 1, 0, 0, 4, 3. But here too, I'll take a break and find my eigenvector values first. So you guys, in this example, I think it'd be okay to expand above the first row. I've only got 2 terms. And I think that leaves me with lambda minus 1. You guys, when I'm walking through this fast, is it okay? Can you sit there and get everything I'm saying, or to think about it, or am I making stuff up out of thin air?
Well, unless you actually did it all in your head, then you're making it up out of thin air.
It's not really making it up, though, is it really?
Yeah. Well,
I'm only asking that because if I'm just walking through things too fast, you gotta tell me. I just kind of assume, since you're not communicating, that through the homework you're proficient with finding these quantities.
I would consider myself proficient, but I don't know if I'm that proficient that I could just compute all that in my head.
Well, yell at me if I'm doing too
Okay.
much. Just yell at me. I don't mind.
But I understand what you did to get to that point.
Okay,
Yeah.
that's what's good. I like that. Is that a lambda minus 1 times lambda minus 3? Oh, minus 0, that's kind of nice. Plus a negative 2 times. Well, the 2 by 2 I generate when I eliminate 2's row and column will give me a 2 times 3 minus lambda. Oh, how nice that is too. Set equal to 0. And if I factor out a lambda minus 3, I think what remains standing is a lambda minus 1 squared. Is that a plus 4? And set equal to 4. But is that going to give me a lambda minus 3 times lambda squared minus 2 lambda? Is that a plus 5? Oh, you guys, that looks pretty rough. Is that correct? I don't like it.
Yeah, that's a bad one.
Because I took a negative sign out of here.
For the very first term, should be a 1 minus lambda.
You know what? I agree with that. I just saw it.
Yeah.
I'm trying to skip steps. And in my head, I multiplied the first term by negative 1 because it makes it look nice. And I didn't multiply the second term by negative 1.